Okay, grade 10s. In this video, I'd like to show you the two-intercept method of drawing a straight line graph. First, I'm going to start off with an example and the way we would have learned how to do it in grade 9. And then I'm going to show you the two-intercept method and we'll see why I'm opting for this one instead. All right, so let's assume we get this example. Draw a neat sketch graph of y equals negative 2x plus 4. In grade 9, the first thing we would have done is we would have popped down a table. We could choose any x values. Here I've just chosen negative 2 all the way through to 2. So we would say where x is equal to negative 2, let's write down our equation, and everywhere we see an x, we're going to replace it with a minus 2, and I'm going to use brackets because brackets are my friends. From there, I'm going to simplify, and I'm going to get that y is equal to 8 whenever x is equal to minus 2. And I'll do the same sort of thing when x is equal to negative 1, and I'll see that it's 6, and so on and so forth. All right, then once we've created our table, we're going to put all of our numbers on our Cartesian plane there, and hopefully yours are a little bit neater than mine. We're going to start with our first point. I'm going to start with negative 2, 8. Remember, in coordinate form, this would be the point negative 2, 8. I'm going to start with negative 2 because I prefer to start with my x values, and I'm going to go from 0, I'm going to move across negative 2, and then I'm going to go from there, I'm going to go up 8, and I'm going to plot my point. And there you go, that's the start of it. And then we're going to do the same for every other one. Let's plot negative 1 and 6. That should end up over there. 0, 4, 1, 2, 2, 0. And that's my table. So now all I do is I connect the dots. Alrighty, so that's how we've done it before. Nothing wrong with this method, except that it does take a little bit longer. Creating the table, doing the table, filling in the table. Just for this one, I filled in and I calculated 5 different points. So let's have a look at the same example, but using the two-intercept method. Now, this method requires you to have a solid understanding of how an equation for a straight line is set up. My standard form that I refer to is y equals mx plus c. Some of you may see it as y equals ax plus q, or y equals mx plus d, or y equals Jeffrey x plus Bob. It doesn't really matter as long as you know what those numbers actually represent. So the coefficient of the x value, which we see here as negative 2, that we need to know is the slope. All right, so here in my version, I'm going to say m is equal to negative 2, and I know that negative 2 is less than 0. So what does that mean? Remember, this little arrow, while poorly drawn, implies that. So because I know that it is less than 0, I can know that the shape is going to look like that. My straight line should look like that. What I like to say is that if my gradient is positive, things are looking up, and if my gradient is negative, things are looking down. In this case, my gradient is negative, so things are looking down. What we're going to do is once we've drawn our picture, we're just going to double check that that's the case. Then, the other thing in an equation of a straight line is this last number over here, which I hope you now know is your y-intercept. Your y-intercept is where your straight line crosses your y-axis. It is important to recognize that when your line crosses your y-axis, the x value there is 0. Okay, so let's just plot this point. So we go there, we go up 4 spaces, there you go. This is only one of the intercepts, and this is the two-intercept method. So now we're going to find our x-intercept. And just like with the y-intercept, our x value is 0. For the x-intercept, our y value is going to be 0. So that's how we're going to calculate it. We can just pop down our equation, replace our y for a 0, and then we're going to move this negative 2x over, and we'll get 2x equals 4. And simplifying, we get that x equals 2. So now we have the other intercept. The other intercept is the point 2, 0. So let's plop that down. So there you go. We've got 2 points. Now all we need is to connect the dots. And because we're in grade 10 and oftentimes we're going to be asked to draw multiple graphs on one set of axes, we must remember to label our graph. There you go. I think that this is a lot quicker, a lot more efficient, and it makes sure that you fully understand what the idea of an intercept actually is. Now let's just double check our slope. Is it looking down? Yes, it is. Remember, we read from left to right. So from the left, it's up at the top, and on the right, it's at the bottom. So it's looking down. Okay, let's do one more example. Here we've got draw a neat sketch graph of y equals 2x minus 1. What I'd like you to do is pause the video and try the two-intercept method and see if you can. If we look at this equation, we can see that the coefficient of x is 2, meaning that our gradient or our slope is 2. And that is greater than 0. It's positive, which means that it's looking up. So that should be the general shape of the straight line. Obviously, it should be a straight line and not wibbly like my arrow. Then the second piece of information that that equation affords us is the y-intercept. So let's go straight ahead to the graph and draw in our y-intercept. So there you go. Make sure that it is below the x-axis since the number is -1. And now finding our x-intercept. We're going to set our y value equal to 0. So we're going to write our equation, but instead of y, we'll have a 0. We'll move some values around and simplify, and we get that x is equal to a half. So we just go onto our graph, we find the spot between 0 and 1, and we plot the point where x is equal to a half. Now, easy peasy lemon squeezy, we connect the dots, and because we're in grade 10 and we want to have good habits, we label our graph as well. Now we can double check our gradient. We see that it is sloping upwards just like we thought it should based on the number or the coefficient in front of the x. All right, guys, I hope that this just gives you an easier way to draw your graphs. You'll notice that before we would put every single number on our Cartesian plane. In grade 10, it is only important that you include the necessary numbers. So in this case, it was our intercepts. So just bear that in mind. You don't have to put down every number from 0 to 10 on either side. You are welcome just to put down the important numbers. Okay, guys, I hope that that was helpful and good luck with the rest.